Hey everyone, just wanted to go through. We've got our very last video for this week. We're going to go over 1.3, which are equations with variables on both sides. All right, so we've gone through some of these multi-step equations. That's what we were covering in 1.2. We finished out those word problems just the other day, and now we're going to get into if we do have variables on both sides of the equation. Okay, so I've talked about just a little bit what to do with that. We're going to get into more detail with this now. All right, so first off, if you need to pause the video, that's fine, but we're going to copy down this definition for an identity. All right, and I'll get more into this later, but when we have what we call an identity or an equation with infinitely many solutions, it means that it's true for any value of the variable. So I can plug in this equation right here, I can plug in any value for x. Okay, because we see that if we distribute out that -2, I'd end up with this -2x minus 2. All right, so if I were to add 2x here to both sides, and then add a 2 here to both sides, everything's going to end up canceling out here. All right, so we're left with 0 is equal to 0. And that's true no matter what I plug in here for x. I can plug in any value for x. This is always going to be true. Okay, so we would call that an identity, or we would say that this has infinitely many solutions. All right. So we're going to get into, here I've got two examples for us for an equation with variables on both sides. Okay, so if it have an equation where variables are on both sides, you want to simplify one or both, okay, of the equation. So that usually just means combine like terms. Then you want to use inverse operations to collect the variable terms on one side and then the constant terms on the other, and then isolate our variable. Okay, so here I've got -18 minus 6x is equal to 6 plus 18x. So we want to say, okay, we want to simplify anything on both sides of the equation, but I don't have any like terms here on the same side of my equation, so I don't have anything to simplify. So it says I should use these inverse operations to collect variable terms on one side and constant terms on the other. Okay, so normally what I like to do is look for any negative variable terms, because then I can add, just because I feel like I make less mistakes when I'm just adding instead of subtracting, but that's just me. Okay, so I can cancel out this 6x. So I've got -18 is equal to 6 plus 24x. Okay, I just add these two things because they're like terms. I don't do anything with the 6 and then the 6x. Okay, so I'm just adding the 18x and the 6x. All right, then I want to collect constant terms on my other side. So I've got a +6, so I'm going to move that over. I'm going to subtract this time. All right, so I've got -18 minus 6. That's going to be a +24. Okay, these cancel out, 6 and -6. Oh, I said it right, but then I think I wrote it wrong. Or maybe I said it wrong too. It's a -24 and then a +24x over here. So I want to get rid of that 24 here. I'm multiplying 24 and x. I'm going to divide each side by +24. I don't know what my neighbor is doing. I don't know if you can hear that. All right, -24 divided by 24, I get -1. And then these 24s cancel out, is equal to x. Okay, -1 is equal to x. Just a little bit, we're going to talk about how many solutions an equation has. This one has one solution. Okay, there's one value of x that works for this, and it's -1. Okay, so let me show you real quick another example. All right, I've got 3n minus 5 is equal to negative 48 minus 40n. All right, first I want to deal with my variables. So you see over here I'm subtracting, so I'm going to add 40n to both sides. Okay, so I end up with 43n minus 5 is equal to negative 48. Okay, these are my like terms, so those are what I add. I leave that negative 5 alone. These cancel out. Then right here, I want to take my constant. I want to move that to the other side of my equation. So of course, I'm going to do that with my inverse operations. I'm subtracting, so here I'm going to add. Okay, plus 5 and plus 5. So 43n is equal to negative 43. All right, this one's looking pretty similar to my last one. So I'm going to say, all right, I'm multiplying there. I want to divide by 43. And those 43's cancel, so I end up with n is equal to negative 1. And again, when you just get n or x or y or whatever is equal to just one number, you've got one solution. Okay, so sometimes I'm going to ask you about that as well. All right, so let me get into what I mean when I was talking about how many solutions. All right, I hadn't really explained that yet. That's over here. Special solutions of linear equations. Okay, so equations don't just have one solution all the time. Right, so like we talked about before, an equation that's true for all values of the variable is an identity, and it has infinitely many solutions. That's what I kind of explained a little bit earlier in the video. Okay, an equation that is not true for any value of the variable has no solution. So for linear equations, which are the type we're doing right now, it can either have one solution, no solution, or it can have infinitely, oh, that's a very ugly infinity sign. It can have infinitely many solutions. Okay, so we've just done a couple that have one solution. You're used to seeing problems that have one solution, but let's look at one here that has no solution. All right, so these you're going to solve them out. So x minus 4 is equal to negative 9 plus x. So let's go ahead. We want to deal with the variable first. So I'm going to subtract x from each side. Okay, so this cancels. And this cancels. I get negative 4 is equal to negative 9. I'm going to shut my window. Negative 4 is equal to negative 9. And there's nothing I can do to make negative 4 equal negative 9. There's no value that I can plug into x that will make these two numbers equal. I don't even have a variable here anymore. So since this is not true, I have no solution. Sometimes you're going to see this written like this, that kind of 0 with the slash through it. Okay, so no solution. So if I have a section on the homework where I'm asking how many solutions does this have, this would be no solution when it doesn't work. All right. Now let's look at something a little bit different. We've got 5 times x minus 1 is equal to 5x minus 5. This is similar to that example earlier. All right, I want to simplify each side. First, I can't just start moving terms around until I've got each side simplified. So I'm going to distribute here. We have 5x minus 5 is equal to 5x minus 5. All right, I want to deal with my variable term first, so let me subtract 5x from both sides of my equation. Okay, 5x minus 5x cancels out. I get negative 5 is equal to negative 5. Okay, when I get something like this where I get the same value is equal to the same value, well, that's always true. Negative 5 is always equal to negative 5. No matter what I plug in for x, since x isn't in this final solution, all right, this is going to be infinitely. I had to think about how to spell infinitely. Infinitely many solutions. Or we can call this an identity. We call it an identity because each side of the equation, as you can notice over here, these sides of the equation are equal to each other. Okay, they're the exact same thing. After I distributed, we had the exact same thing on each side. So it doesn't matter what I plug in for x. If you plug in 1 or 13 or 13,000, this is always going to work and it's always going to be equal. All right, so sometimes I'm going to ask you about that. How many solutions does it have? Okay, if you end up with x is equal to a number, okay, that's one solution. If you end up with two things that aren't equal, so 3 is equal to 5, okay, that's no solutions. And if you end up with two values that are equal to each other, that's infinitely many solutions. Okay, if you have x is equal to x, infinitely many. 2x is equal to 2x, okay, same thing. If you have two things that are the exact same value, those are all infinitely many solutions. All right, and just to point out one very last thing, we've already taken notes on this, so I'm not going to spend a ton of time on it, but as you're going through and we're getting in these more and more complicated equations, just make sure you know the kind of order to work through this in. Okay, so first off, you want to make sure you don't have any grouping symbols. Okay, by that I really mean parentheses. Okay, so distribute out anything. Make sure each side is simplified. Okay, so really combine like terms. Make sure all the variable terms are on one side and the constant terms are on the other side. So a lot of times that means you're adding or subtracting those terms. Okay, isolate the variables, so you're using those lovely inverse operations. And then always check your solution. Okay, you guys saw in my last video, I think, that I made some goofy math mistake. All right, and I caught it because I go back and I check my solution. All right, that saves you in case you're on a quiz or a test. You want to make sure that you've got those right answers. You want to make sure your answer makes sense. All right, so go ahead. You can start on your 1.3 assignment. And then really we just have one more section. We have 1.4 and then we're done with chapter 1. All right, I'll see you guys tomorrow.